Welcome to Lesson 61 of Saxon's Algebra 1, 3rd edition. This lesson is on sets and subsets of the set of real numbers. Now, set notation, on the next page, I have got some things for you to put in your notebook about sets and how we write that mathematically. But basically a subset means a set inside of another set. We can say here A is a subset of B if every element in A is also in B. For example, if we say that the set A includes 1, 2, and 3, and B includes 1, 2, 3, 4, and 5, then we can note it as this. A is a subset of B, and that's the symbol. A is a subset of B because there's a 1, a 2, and a 3, so every element of A is included in B. Alright, now here's some of the notation. Some of these you're not going to be using, but it's good to have them here anyway. So, this one right here, subset, we'll be using. Not a subset, we'll be using that one. And I thought it was good for you to know that this one here, the 0 with the slash through it, that means the empty set. Alright, so set A consists of 3 people, Alice, Stephen, and Jane. So the subsets of A, we can say B is Alice, Stephen, Jane. So B is a subset of A because it contains every element. C only has Alice and Stephen. So C is a subset of A because Alice and Stephen are in A, but Jane is not. So if we say C contains Alice and Stephen, that does come under the set of A. D, Alice and Jane. And you see how we can rearrange them in several different ways. Alright, if you're in my classroom doing this math, you're going to get a handout for your interactive notebook that will have this chart, and it will be blank. And I will be asking you to use this information. You also have the chart in your book, and I frequently have to tell people to turn back to look at this chart, so I thought it'd be very handy for you to have the chart in your interactive notebook and have it handy. If you are doing this as an online course and you're not in my classroom physically, I would suggest taking a large index card and making a copy of this so that you can have it handy as a handy reference. But basically, all of real numbers, and let me see, let's move this down a bit. And we're going to say this is real numbers. And believe it or not, there are some numbers that are not real numbers. They're called imaginary numbers that you will get to in the next course, Saxon Algebra 2 course. But for now, we're going to only look at real numbers. And so we're going to say under the set of real numbers, we have all of these sets. We have rationals, and a rational basically has, well, let's start from the inside, okay? So you have your natural or counting numbers. Those are the ones that, if you're naturally counting, you start at 1. You don't start at 0. So these are 1, 2, 3, and continue forever. Now, whole numbers also include the natural numbers plus 0. So we can say that the natural numbers or counting numbers are a subset of whole numbers. Both of these are a subset of integers. Integers are positives and negatives plus 0, but they only cover on the number line those exact numbers. They don't cover anything that comes between them. That's where you get into rationals. Rationals is all the things that come in between 1 and 2 on the number line. So decimal numbers, fractions, all of those are considered rational numbers. Now, on the outside of the set of rational numbers, see, we have rationals, and then subsets of rationals are integers, whole numbers, and natural numbers or counting numbers. On the outside of that set, we have irrational numbers. Now, irrational still falls under the set of real numbers, but these are numbers that would be represented by either pi or the square root sign. Usually it is a square root sign that you're going to consider an irrational. All right, I found another couple of charts to help you visualize this. This chart has included the imaginary numbers that we talked about. And you can see maybe in this one a little bit more clearly. All of these are real numbers except for these imaginaries. And in the purple box, you have rationals and irrationals. And irrationals have no subsets, but rationals has a subset of integers, wholes, and naturals. Integers has the subset wholes and naturals, and whole numbers have the subset natural numbers or counting numbers. Also, another way to visualize it, you've got a big mixing bowl, and then you've got cups of stuff that are going to go through the, think of these as stacking like measuring cups, maybe, if you will. The bowl is going to hold all real numbers. So that will include your rational numbers and your irrational numbers. But under irrational, in the stacking set of bowls, we can stack the integers into the rationals, and then the wholes, and then the naturals. All of that goes in as a real number. All right, your practice problems, given the sets A and B and C, and you can see what are members of those sets, tell which of the following assertions are true, which are false, and why. Now, I want to show you these little symbols right here are the closest thing that my keyboard would allow to resembling something like set, but they really should be more of just like this, okay? So don't get confused and think that's really another set notation that you missed. All right, so let's see. In 1, is B a subset of A? Well, B includes 0, 2, 4, and 6. A includes 0, 1, 2, 3, 4, 5, 6, and it keeps going. So we can say yes, this is true because every element in B is included in A. Number 2, B is a subset of C. Well, C includes 1, 3, 5, and 7. Those are odd numbers. B only has 0, 2, 4, 6, the even numbers. So this would be false because none of the elements of C are in B or B in C. All right, number 3, C is a subset of A. Well, that would be true because A includes all of the whole numbers, and that would include 0. So every element in C, 1, 3, 5, and 7, would be contained in set A. All right, now this is where problems like this, and you're going to continue to have them throughout the book now, are going to have you list, for example, the number 11 over 6 is a member of, and that's what this little symbol means, is a member of what subsets of real numbers? So you've got to look at your little handy-dandy chart, reference chart that we've got, and say 11 over 6. Now that is a fraction, so that makes it a rational number. So then we would say reals and rationals. Okay, it does not include integers because it's not a strictly whole number. All right, C, 0.62 is a member of what subsets of real numbers? Well, a decimal is going to be the same thing as a fraction. It's still going to be reals and rationals. Four is a member of what subsets? All right, now that's going to take more. We know it's a real number. And if it's a real number, it's in the category rational numbers. It is an integer. It is a whole number. And it is a natural or counting number. So for D, we had several then, didn't we, that we had to list. So that's how you can see why I say that it's going to be really handy to keep that chart with you all of the time. All right, E, we have that little square root sign. So that is going to be, they're all going to be a member of the set of reals. But square root, we said, is an irrational. So irrationals. All right, and then F, -4. Well, -4 would fall under reals. It would fall under the subset of rationals because it is actually an integer, and integers are part of the set of reals and rationals. So there you go. As long as you keep that little chart handy, I think you'll have no problem at all with these problems. And I will see you back for lesson 62 next time.